This is section 10.2, part 2, and we'll be looking at arc length. The arc length would be the unbroken fraction of a circle. So instead of doing the entire circumference of a circle, I could just do part of that circumference, and we call that the arc length. So I have points A and B which are on the circle. I could find the measure of arc angle AB. That means how many degrees are you rotating around the center point. But what I'm interested in right now is what is arc length AB? What is the length of that segment if you're walking around the circle just for that fraction? What is that distance? Well, the way we find arc length is to go back to circumference. Instead of doing the entire 2 times pi times the radius, we need to look at what is that central angle, and we take x over 360 times the 2 pi r to get the entire arc length. That tells us what fraction of the circle we're dealing with times the entire circumference. Look at a few problems here that look at the differences between the different objects that we've talked about so far. A and B and CD are diameters. The length of segment CD is equal to 8, which means that the radius is equal to 4. And we want to find these measurements. First of all, measure of angle ARE. Since this angle is 90 degrees and they're perpendicular diameters, it means that this angle is 90 degrees. We have a central angle of 20, so angle ARE is 70 degrees. Measure of arc angle DE is 20 degrees. Notice it has the little M in front of it. That's why we know it's the arc angle. Measure of arc angle EAC starts at E, passes through A, and ends up at C. It's not quite an entire 180 degrees. It's 20 degrees short of that, so it's 160 degrees. Measure of arc angle EBA starts at E, passes through B, ends at A, so it's a major arc. It's 70 degrees short of being an entire 360, so it's 290 degrees. Then we have arc ED. ED is the length of this segment. There's no M in front of it, so we're not looking ultimately for the arc angle. We want to know if you started at point E and walked along this arc to point D, what is that length? The central angle is 20, so it's 20 over 360 times 2 times pi times a radius of 4. And we can look to simplify this. Divide those both by 10. 2 times 4 is 8. 8 times 2 is 16 pi over 36. We can simplify that a little bit further. Divide that by 4. Divide that by 4. So we get an exact answer of 4 pi over 9. And then you can multiply that out. Take 4 times pi divided by 9. And get an approximate length of 1.40 units. Not units squared, it's just units. Then we're asked to find the length of arc EB. There's only 2 letters, so it means we're dealing with the minor arc. What is that length? A lot of this will have the same numbers as the previous one. This time the central angle is 20 plus 90, so 110 over 360. Times 2 times pi times the radius of 4. Divide those by 10. 8 times 11 is 88 pi over 36. We can divide these both by 4 and get 22 pi over 9. So there is the exact answer. And then multiplying that out, we get an approximate answer of 7.70 units. This is the last example on section 10.2. The directions say to find the length of the red arc. So starting at this point, traveling along the red arc and getting to that point. We're told that this arc is 20 inches, and it is an arc length. So I could say that 20 is equal to 100 over 360 times 2 pi r. The reason why I'm setting up that equation is so I can find the length of segment r. Now if we do the algebra on that, multiply both sides by 360 over 100. Simplify that down a little bit. I can divide this by 10, divide this by 10, so it's 72. And I'm also dividing both sides by 2 pi, so I can get r all by itself. Divide that by 2, divide that by 2, and the radius as an exact value is 36 over pi. Using that, I can go forward and find that arc length. Arc length is central angle of 2 260 degrees over 360 times 2 times pi times the radius of 36 over pi. This will simplify down a little bit. Pi over pi cancel out. Divide by 10, divide by 10. You can divide this by 2, divide that by 2. This is in the numerator, that's in the denominator. Divide this by 9, divide that by 9, and I have 13 times 4, which gives me a length of 52 inches.